Hi, I'm Alejandro Martinez, and I'm going to be doing problem 2.43. In this problem, we have two cylindrical metal tubes, one of radius A and the other of radius B, and we're asked to find the capacitance per unit length of both. So, to start the problem, it's going to be C is equal to Q over V, and it is easier to find V in this equation, so V is going to be equal to VB minus VA. And then to find VB minus VA, it's going to be equal to the negative integral of the electric field dotted with dl. And in this case, we're going to find the electric field. So the electric field is going to be equal to, electric field equal to the integral of electric field dot dA, and that's going to be equal to Q enclosed over epsilon naught. Now, we're going to use Gauss's law because we are drawing a cylinder, a Gaussian surface around this, and we are trying to find the charge and find inside to find the electric field. So, to do this, we have to know what dA is. Now, dA, we're going to treat this circumference of the circle, 2 pi s, and we're going to be integrating it across the length of L right here. So all the way across. So we're going to have the electric field dot 2 pi s in the s hat direction is equal to our Q, which is the Q enclosed, or total charge, over epsilon naught. Let me double check my notes, make sure we are still correct. And looks good. Okay. We can go ahead and find the electric field by pulling this over to the other side. So Q over epsilon naught, times L. There we go. Because the length that we're integrating over. 2 pi s L. And that's going to be in the s hat direction. Let me double check. And looks good. Okay. Now that we have this, we're able to plug it back into here. So I'm going to go ahead and rewrite that. VB minus VA is equal to Q over, the negative integral of Q over epsilon naught 2 pi SL. And then this is going to be S hat dot DL. So our DL is going to become DS. The reason for that is because we are integrating, we are taking the path radially out. So we're going to put DS since we're only in the S hat direction. So dot DS. And we can go ahead and start solving this problem. So negative integral of Q epsilon naught 2 pi L. And then we are going to pull out that S. So we're going to have 1 over S. And it is from A to B. From A to B. S ds. Okay. So on the integral, we are going to have Q over epsilon naught 2 pi L. And it's going to be outside since it isn't directly being integrated, only S in this case. And then 1 over S just becomes ln of S from A to B. And then we are able to remember that it would be Q over epsilon naught 2 pi L negative ln B minus ln A, which this becomes ln B over A. So to clean this up, this becomes negative Q over epsilon naught 2 pi L and then ln B over A. And this is going to be equal to our VB minus VA, or our total in terms of V. Now, in this problem, as you can see, our potential, A has a higher potential as told in the problem. So for this one, this is actually going to be negative because it would be VA minus VB. So our V would be equal to Q over epsilon naught 2 pi L ln B over A. And it doesn't make sense because how we are finding capacitance, you can't have a negative capacitance. That's not what a capacitor does. So to finish the problem, capacitance is equal to Q over V. And we're going to have Q over Q ln B over A over epsilon naught 2 pi L. Now, the L is going to cancel out because in the original problem, it's asking us for capacitance per unit length. So this L we can go ahead and get rid of, as well as these Q's. They're going to cancel out, and the epsilon naught 2 pi is going to go to the top. So we're going to end with our capacitance is equal to epsilon naught 2 pi over ln B over A. Let me double check my notes to make sure that is the final answer. And 2 pi epsilon naught or ln B over A. And that's going to be our final answer for the capacitance.